Hello students, welcome to Akshara 8 Foundation. So today we are going to discuss the concept based questions and exercise problems based on the last class. In the last class we have discussed about the moment of inertia of different bodies. So based on that we will see the conceptual based questions. Okay. So first question is given here. The following pair of physical quantities are analogous to one another in translatory motion and rotatory motion are. Okay, that means so analogous to one another in translatory motion and rotatory motion. So the physical quantities which is in translatory motion and it is same, that physical quantities will be here what is there. So that physical quantity they are asking there here, mass and moment of inertia. So mass is it is a physical quantity in the linear momentum. So the same. It will be the function of mass, what it will be there in the translatory motion, the same function will be leads by here the moment of inertia there. So, okay, mass and moment of inertia are the analogous to each other there. Okay, so then the mass will be considered in the rotatory motion, moment of inertia as the mass. Okay, then force and torque. So force will be in the rotatory motion and torque will be in the force will be in the translatory motion and torque will be in the rotatory motion there. Okay, the linear momentum will be in the linear motion, translatory motion, and angular momentum will be the momentum of a body in the rotatory body. So we can write here options are all of the above. So for first question, we can write there, they all are analogous to each other there. Okay, analogous to each other. Analogous means, so what is the function of mass will be in the translation motion, same function will be done by the moment of inertia in the rotatory motion there. Okay, like that. So even the force is in translatory motion and the same torque will be plays a same role in the rotatory motion there. And linear momentum will be, it is in the translatory motion, the same function, same role will be played by the angular momentum in the rotatory motion there. Okay, then all of this. So we can add there all of the above answers. Then here second question is given. A boiled egg is a raw egg. A boiled egg and a raw egg of same mass. Boiled egg and a raw egg of same mass and size are made to rotate about their axis, about their own axis. If the I1 and I2 are the moment of inertia of the boiled egg and the raw egg, then what is the relation between the moment of inertia of the boiled egg and the raw egg there? If they are moving, if they are rotating about their own axis there, perpendicular to its plane there. Okay, so then moment of inertia, moment of inertia will be depend on the mass of the body, mass distribution of the body about this axis of rotation, and each and every particle, the center of mass will be from where there, from the axis of rotation there. So suppose if it is a boiled egg, the mass it will be act like a rigid body. So then mass will be constant about the axis of rotation. But whereas in the it is unboiled egg there, raw egg, so there is a mass will be, whenever it is rotates there, mass will be continuously, it will be rotated there. Okay, it will be changed according to the position of the mass of the particles of the raw egg will be changed according to the rotation, according to the from the reference to the axis of rotation there, so that the mass will be distributed. So then moment of inertia will be decreases there. So it will be constant, then the moment of inertia will be I1 will be greater. In the raw egg will be it is in the boiled egg will be, it is greater there, and the moment of inertia will be changed due to the change of mass in the raw egg there, because it is a liquid, so liquid will be there. That liquid may be changes whenever it rotates there. Okay, it will be move away from the, means all the mass will be it will be present at the periphery of the egg there. So oval elliptical shape of the egg there. Okay, so due to that the moment of inertia will be decreases there. So then here we can add the second option, that is moment of inertia is second option is right there. That is the first one. Moment of inertia is first one is greater than the moment of inertia of the second one. Okay. Next, radius of gyration of the metallic disc is independent of the following physical quantities. So moment of inertia of the radius of gyration of the rotating metallic disc. Radius of gyration. So radius of gyration formula is what there? So the radius of gyration is nothing but the perpendicular distance from the axis of rotation to the center of mass of the body, or it is the root mean square value of the all the particles. Root mean square value of the all the perpendicular distance of the each and every particles of the body. Otherwise, we can say the perpendicular distance from the axis of rotation to the center of mass of the body is said to be the radius of gyration. So we got the formula of this. This one is, we can write here. So r1 square plus r2 square plus r3 square plus so on up to here rn square divided by here n times. So this is the root mean square value of the all the distances, perpendicular distance from the axis of rotation to the each and every mass of the particle of each and every mass of the particles of the whole body there. Okay. So this is the root mean square value of the distances. So RMS distances of the each and every particle distances. Okay. So that is the radius of gyration. So it is not it will be depend on the distances, perpendicular distances and number of particles are there. So here the position of the rotation and radius of the disc and mass of the disc and temperature of the disc. Okay. So then we can write here, it is not depend on, there is no mass term here. So it does not depend on the mass. So we can write here, that is the mass. So second option, option 2, mass of the body. Mass of the body. It does not depend on the mass of the body there. Okay. So next, fourth one is given here. Two satellites A and B of equal masses, which can be considered as a particles are orbiting the earth at different heights where HA and HB. Then so two satellites is given there, A and B. So one is, they are of equal mass, which can be considered as a particles and orbiting the earth at different heights there. HA is greater than HB. So height of the satellite is greater than the height of the second satellite B. Height of the satellite A is greater than the height of the satellite B there. Then the moment of inertia of the satellite. So here A has a greater moment of inertia and B has a greater moment of inertia. AB has the equal moment of inertia. So moment of inertia of the satellite is 0. So which one is correct? They are asking there. Which one is right? Okay. Moment of inertia of the body. So here the options are given. A has a greater moment of inertia. B, second option is given there. B has greater moment of inertia, and A and B has equal moment of inertia. The moment of inertia both satellites is 0. Okay. So the moment of inertia is, we know the formula of the moment of inertia. It is I is equals to m into r square. No, m into r square. M into r square there. So this is what there here. Suppose. So we can write here moment of inertia of this particle satellite A we can consider there. So it has a mass m there. Mass into here the distance what they said there here height. So it is moving about the around the earth there. We should consider the center. So axis of the earth is the center. Axis of the rotation of the earth they are moving there. Then this h square itself will be the the perpendicular distance. Okay, from the axis of rotation to the mass of the body there. Okay, so h we can write there. So the same way here IB we can write here, IB is equals to m into HB square. Now. So they have given already here HA is greater than HB now. HA is greater than HB in the question they mentioned there, means the height of the satellite A is greater than the height of the satellite B. So if it is greater, then what will be the, which moment of inertia should be greater than? So it should be definitely, so this IA is greater than IB. IA is greater than IB. It should be greater than IB. IA is greater than IB. Okay. So that is the answer. So we can write here, so first option. So A has a greater moment of inertia than B. So first option we can write there. Fourth one is, this is the answer. Okay. Now fifth one we will see here. The moment of inertia of a uniform thin rod of mass m and length l about an axis passing through its center perpendicular to its plane is given by. Already we have done this one, no? So we have found the moment of inertia of a uniform rod. That is ml square by 2. It is perpendicular to its, about the length they are asking there. Center of, about the length. The moment of inertia of the rod, uniform rod of mass capital M and length capital L about an axis passing through its center and perpendicular to its length is given by. Perpendicular to its length. So it is, we can write here the moment of inertia of that body is ml square by 12. ml square by 12. We have found this one. Okay. Now the fifth one is ml square by 12. Suppose if it is the moment of inertia of the uniform rod of mass m and length l and the breadth is b there, then the moment of inertia about the center passing through its center and perpendicular to its breadth. If it is taken then, so mbl square by 12 will get there. Okay. So next sixth one is given there. What is the moment of inertia of a uniform circular ring of mass capital M and radius r passing through its center perpendicular to its plane or transfer to the axis there? So that we have know that it is the sixth one, mr square, no, moment of inertia of a ring there, mr square. I given that there is a mr square will be the answer. So this is the moment of inertia. For fifth one is ml square by 12 there. And sixth one, what is the moment of inertia of a uniform circular disc of mass m and radius or capital R passing through its center perpendicular to its plane there. Okay. Uniform circular disc. What we got there? So mr square by 2 we got now. So there is option 2. So seventh one is mr square by, there is mr square by 2. mr square by 2 we can write there. mr square by 2. The radius of the gyration of a rotating circular ring is maximum about the following axis of rotation. So the radius of gyration of the rotating circular disc is maximum about the following axis. So in which case the moment of inertia will be greater, they are asking there. Natural axis, axis passing through its diameter of the ring, and axis passing through its tangent in the ring, it's a plane there. Axis passing through its tangent and perpendicular to the plane of the ring there. So from this all, which one is the correct answer they are asking there. So we have found there at the different positions now. The moment of inertia about an axis passing through its center. So we can write here the moment of inertia of a body. So axis passing through its through a tangent of the ring about its plane. That is a greater maximum about axis of rotation there. So moment of inertia will be dependent about the axis of rotation there. So if it is passing through its tangent of the ring in its plane. Okay, so in that case it will be the maximum there. So eighth one we can write that is the mr square by. So we can write here 3 by mr square by 2. This will be the maximum there, 3 times. So greater than this it will be there, no? In the remaining all the cases we got there. This one is the 3 mr square by 2 will be the moment of inertia. So it will be the option 2. Option 2 is right. The moment of inertia about the tangent along its plane. It is 3 mr square by 2. That is a right answer. Now ninth one. The moment of inertia of a square plate ABCD of uniform thickness about an axis passing through its center O and perpendicular to the plane of the plate. So the moment of inertia about this one, ninth one they are asking there of square plate. Ninth one, square plate is like this. The square plate is like this. Okay, and the moment of inertia they are asking the passing through its center perpendicular to the plane. Suppose if you consider this is a square plate, then the moment of inertia about this axis, about the own axis they are asking there, about the own axis. Okay. So here it is given there moment of inertia I1. So diagram is given like this. This is first and second, and this is the third one, and this will be the fourth one. Like this they are given there here, and ABCD. This is a A, B, C and D. Okay, and the moment of inertia about BC, it is I1 is given and this is a I2 is given, and about the diagonals, about the diagonal is this is a I3 and this is a I2, I4, this is I4 there. Okay. So now moment of inertia about this axis, about the axis perpendicular to its plane, it is passing like this then. So in this case, if the moment of inertia about this axis they are asking there, they are asking about its own axis, then how to write there? So the moment of inertia about this axis. Now if it is passing like this, then this I4 and this I2, I4 and I2 will be the perpendicular, no? Perpendicular to each other there, perpendicular to each other. So we can write there by using the perpendicular axis theorem. By using the perpendicular axis theorem, what can we write there? So we should write there perpendicular axis theorem there. So then we'll get there I1 and I3, I1 and I3. So the moment of inertia is passing about this one, about the plane. So this will be the, it is perpendicular to these two mutually perpendicular axes. So that we can write here this I1 and I3. So the moment of inertia about the center I0 is equal to, we can write there I1 plus I3, we can write there I1 plus I3, I1 plus I3, I1 plus I3, even we can write there I2 plus I4, even. So I2 plus I4, according to this is also equal to I2 plus I4, the perpendicular axis here. These two axes also perpendicular. So we can write here I2 and I4. So we can write the answer is what there then? Answer is first one. A and B are true. A and B are true there. First option is right one. So by using the perpendicular axis theorem, what it says that? It says that the moment of inertia about the any axis is equal to the sum of the moment of inertia about their mutually perpendicular axis. See here, this is the moment of inertia about the plane, means the square plate. The diagonals also perpendicular to this this axis, and even the bisectors, bisectors of the square also they will be perpendicular to each other. So perpendicular to each other. Then the moment of inertia we can write there. The moment of inertia about the axis perpendicular to the plane of square plate, it can be written as I1 plus I3 and I2 plus I4 also. Okay. The next one. Okay. So next 10th one, identify the increasing order of the radius of gyration of the following bodies of same radius. So here there are different options are given there. So from that all the four options, which set of the options are correct there? In increasing order we have to arrange them there. The moment of inertia. So we should write the radius of gyration there. About natural axis of circular ring. So the moment of inertia of the circular ring, what can we write there? The moment of inertia of the circular ring. The moment of inertia of the circular ring, we can write there circular ring mr square now. The moment of inertia of the natural axis, about the natural axis of a circular ring is mr square. And about the diameter of the circular ring. About the diameter of the circular ring. About the diameter of the circular ring, what can we write there? So that can be written as here. So mr square by 2 will come. It will be right now. It will be come now. So the moment of inertia of the circular ring about the diameter. So that can be written as here mr square by 2. Mr square by 2 will write there. Mr square by 2. The moment of inertia of the circular plate. There is nothing but the disk. About the diameter of the circular plate. The moment of about the diameter of the circular plate. about the diameter of the circular plate. About the diameter of the circular plate means diameter of the circular plate. So diameter of the circular plate means it is a disc, we can say there. Okay. So about the axis. See, suppose the about it is a circular disc, the moment of inertia of the circular disc about axis passing through its center perpendicular to the plane, that we got here mr square by 2, mr square by 2. So now if you take the diameter, if you take the diameter of this circular ring, if you take like this, so these two will be the perpendicular to that. Then here we can add there. So I is equals to I2 into Ix we can add there. So Ix can be written as here I naught by 2. So that we can add here mr square by 4 will get there. mr square by 4. mr square by 4 will get there. So now the moment of inertia of the circular disc here about the diameter, circular disc here, circular disc about the diameter will get here mr square by 4. mr square by 4 will get. mr square by 4. We should apply here the parallel axis theorem and perpendicular axis theorem. Okay. So next one is given there about the diameter of the solid sphere. About the diameter of the solid sphere. So the moment of inertia about the diameter of the solid sphere, we have the formula. The moment of inertia of the solid sphere. Diameter 2 by. So the moment of inertia about the solid sphere we will get there. Solid sphere. So this is 2 by 5 mr square will get there. 2 by 5 mr square. So this is a 2 by 5 mr square. 2 by 5 mr square. So now which one will be lesser the one then? So this is 2 by 5. So this will be lesser now. About the solid sphere it is lesser one. So then we can write here the answer. What can we write the answer here? So we can write the answer as this one. So we can write here this one, circular plate, which is so increasing order. We should arrange them in the increasing order there. Increasing order means which one will be lesser one. So lesser one will be okay, this one mr square by third one will be there. This third one will be there. The next increasing one will be the this one will be there. Fourth one will be there. This one solid sphere will be there. Next later this second one, and this is the third one there. Okay, so we can write here the answer as option 3. Third, so this will be the greater. This is a smaller one. Next smaller one will be this one. So we can write here first. This is the first one, and it will be the second one, and this will be the third one, and this will be the fourth one there. So that means here we can add there this third one. So third one, this is the third one, it is the third one, and next fourth one, third one, fourth one, and second one, and first one. This is the order. So we can write the options are fourth, third, second, and first. Okay. So here this is a smaller one, and later the smaller one will be this will be the smaller one. The next smaller one will be the moment of inertia about the solid sphere. The next one is the next greater one is mr square by 2, and final greater one is mr square. That is a mr square. Okay. There is a 10th one there. Now 11th one we will see here. Identify the decreasing order of the moment of inertia of the following bodies there. Same as same mass and same radius. About the circular ring and about the circular plate, about the tangent of the circular ring perpendicular to its plane there, about the circular ring. So he tells, so this also can be written as same, like this only we can do that. So you can find out the moment of inertia of the same. So we will get here there is a fourth option is the right one. Fourth option. So third, fourth, and first, second. Third, fourth, and first, second. 11th one is third, fourth, and the first, second. Same like this, only 10th one. So like 10th one only we'll do there here. That is a fourth option is right. Fourth option is right. That means here the fourth option is what here? Third one is and here fourth one, and first one, and then second one. That is the order. Okay. So point size dense bodies of same mass are attached at four corners of a light square frame. Identify the decreasing order of their moment of inertia about the following axis. So passing through any side, passing through opposite corner, bisector, perpendicular to bisector, and perpendicular to plane, passing through any corner there. So here also we should find out that it is a dense bodies, point size dense bodies of same mass are attached four corners of a light square there. So we should, light square means we should take their mass of the square plate will be we can neglect that one, so that we can write there no need to consider the mass of the square plate because it is given the light. Then the masses of the dense sized bodies of same mass we should consider there, four masses. Then we write here each one is a m mass. If we consider there four masses, we can take into the consideration. Then 4m square, 4 passing through any side. Square plate is given, no? Square frame. It is a square frame, and the mass of that square frame, it is like a frame. The mass does not present at the center there. Only the frame has a mass, even though we should not consider that. So here this four dense masses of the bodies we should consider there. Now here the center of mass. First one they are asking there, the center of mass passing through any side. Center of mass passing through any side there. So center of mass of the bodies passing through any side. So about this one we can add there. About this one, first one is it is the first one, center of mass about this axis. You can add here I1, and the next center of mass passing through opposite corner. Center of mass passing through opposite corner. These two will be same no, actually. So center of mass passing through this opposite corner there. Opposite corner passing through any side, and opposite corner. Opposite corner means it is not like that. It is like this. So it is like this. Any corner means it will be like this there. About this corner, the center of mass of this body, center of mass of the, and passing through any so it has been given like this. Passing through the any side means we can consider any side there. This one we can consider there. And here, so here what are the masses are there? Two masses are there. Then so center of mass about this axis means two masses are rotating about this, and these are at the on the axis only. Then here we can add there square. This is a same side, no, same side. So there is a distance between them. Here it is the same. Let us consider there L square. Suppose the length of the side of the square, we can write here L. Then the moment of inertia about this of the body, we can write here I is equals to 2 into m. And these bodies are rotating about this, no, with perpendicular distance. Here we can add there. So L square we can add there. 2 ml square we can add there. 2 ml square. So two masses and their L distance, perpendicular distance between these two is L only. So 2m into L square we can add there. That is the moment of inertia about this side. Okay, and the passing through opposite corner. Passing through opposite corner. Okay, the axis passing through opposite corner then. So passing through opposite corner means, so this one, no, opposite corner there. Opposite corner means any corner we can consider there here. Suppose if it is passing like this about this corner there, about this one, the moment of inertia of the body about that corner there. So now here the perpendicular distance. So here we can add there. So there is a first one and second one we can add here. Now the about this axis. So here we can add there ml square plus 2 ml square plus here we can add here m into root 2. Distance we will get there root 2 L, no? Root 2 L whole square means here root 2L whole square. So we'll write here root L. So we'll get here 4 ml square will get there. 4 ml square. Okay. And perpendicular to bisector of any side. Perpendicular bisector. Passing through perpendicular bisector. Perpendicular bisector means it is passing like this. So it is it would be like this. Perpendicular bisector. Perpendicular bisector means now, so all the masses are moving. Suppose this is the one side. If you consider there, it is moving like this there. Perpendicular bisector there. So this axis of rotation, and here to here the mass will be, it is half and it is half there, and now the remaining two masses will be at a distance L there. Okay. So we'll get there, that is moment of inertia about this one. The moment of inertia of the, means here we'll get there. So here m L square by 2 means we'll get here ml square L by 2. So L by 4 will come now, means here we'll get there ml square by 2 will get there, ml square by 2 plus, next remaining two bodies, remaining this two are the half of the distance from the axis of rotation, two masses, and other mass, both the masses at a distance of L there. So at a distance of L means here we can add there, so 2 ml square we can add there, 2 ml square. Okay, that is a moment of inertia of the two masses about that axis of rotation there. So now here, so and perpendicular to the plane passing through any corner. Okay, so okay, now this one, second one only we should consider. So opposite corner means, okay, we can take like this. So perpendicular means already we have taken this one. So this we can write here the fourth one, and this will be the first one, and this will be this moment of inertia will be, we can write here perpendicular bisector of any side. So this one we can consider, third one we can consider. Now second one we should write there, passing through opposite corner. Passing through opposite corner. Means it does not perpendicular. Okay, we have taken the perpendicular. The perpendicular corner means it will become around fourth one. So fourth option will come now. Perpendicular to the plane and passing through any corner there. So this is a fourth one we can consider, and second one we should consider, it is passing like this. Means about this it is rotating there. Even if it is rotating like that, so then the perpendicular distance. So here the perpendicular distance, this one will come there here. Now this, it is a L. If you consider this is a L, and this also L. Okay, this this one will be the root 2L will be there. Root 2L, and the perpendicular distance, this can be taken here, that is L about that axis. So it could be, so perpendicular to the, it is moving around the corner there. Okay, like this if you consider there, means the square plate will be rotate about this axis there. It will be rotate about this axis. It will be rotate like this. The square plate will be rotate about that one. So we can write here, that would be, so root 2L means L square means 2 ml square will come there, and here this one and this one. So here we should write there this 2. Okay, so this perpendicular distance we should write there, axis of rotation. Okay, so if this is a L, that is L we can consider now. For that, so this is L means, and here this is a 90. This 90 means, so this theta means 90 minus theta will come there, and here. Okay, ML in terms of sine, in terms of theta it will come there. So that would be lesser only. So I2 will be here. I2 can be taken as lesser value than this one. So which one will be greater there? ml square by 2. This one will be greater one. So here they are asking there, we should arrange them in the increasing order now. Moment of inertia. Initially decreasing order of their moment of inertia about the following axis. So decreasing order. decreasing order. So greater to, so this one is greater, fourth one is greater, and the next, so yes, this is a greater, okay, and next one will come this one, and so this one will come there. So 4 3 4 3 1 2 4 3 1 2 will come there. 4 3 1 2. So first option will come there. So here we can write here 4 4 3 1 2. 4 3 1 2 will be the answer. This is the answer there. Okay, that is the answer. So in that manner we can find out there. Okay. So next one, 13th one, last one here in the concept based questions. So let IA and IB be the moment of inertia of a body about the axis A and B respectively. The axis A passes through the center of mass of the body and B does not. Okay. A and B are the moment of inertia of a body about two axes A and B respectively. The axis passes through the center of mass of the body and B does not passes. Then the moment of inertia about that one. The moment of inertia it is passing through. So it will be, so it is moment of inertia which is passing through the, this one it is greater only, no? It is passing through the axis, that will be greater only. So we can write here then, the moment of inertia are parallel, the moment of inertia about the axis, both are parallel axis there, okay? The moment of inertia of the, if the moment of, suppose if you take a body like this, then this is the center of mass if you consider that, the moment of inertia about this axis. So we can write here I is equals to mass of the body and square of the perpendicular distance here. So we can write here about this radius of center of mass we can consider there, okay. So that is the mr square we can write there. And next one is it is parallel axis they consider there, it is not passing through this one. Then the moment of inertia is, which one would be greater there? So about that axis would be the greater, no? So then moment of, if they are parallel, the moment of inertia is A is lesser than B. So here the moment of inertia is about this axis, because it is IA plus mr square we should take there, no? IA plus mr square we can take there because of the parallel axis theorem. So this would be greater there. So then IB is greater than IA if they are parallel axis. Okay. So that is the answer we can write there. Third one will be the answer. Okay. So remaining exercise problems we will see in the next class. Thank you children. Have a nice day.